All right, good morning, everyone. Thank you for attending the talk. My name is Phani Gangula, Solutions Architect at ZettaScale. So the speaker is right behind me, so it's a bit loud. So today, the talk is about how we can scale systems that built upon DDS and MQTT using Eclipse Zenoh. So before I run into talk, I want to ask the audience, how many of you are familiar with DDS? Even the concepts, nice. And how many of you are familiar with MQTT? Well, there's a great number of audience out there. So any takers for Zeno, at least the concepts? Okay, good to know. So I have some introduction to all these communication protocols, but more about Zeno will be introduced in the talk. So you have some, if you don't have the previous knowledge, it will be covered during the talk. So without further ado, I want to tackle the scalability challenge, what we have today. Let me give you my experience when I was working on one of the projects in my previous company where we were building wireless sensor system. So sensors were basically sending the information to a central controller. So we were building a homegrown communication protocol, which was home-cooked. And then there is another specification on how to put this information on the Modbus registers. It's another 100 pages of specification. So I have rather learned Klingon than reading those specifications, to be honest with you. So then we wanted to provide an interface on this wireless controller so that the customer can store this information somewhere onto the cloud. So MQTT could have been a nice option, but we went for a RESTful service, so push this data into the cloud. So in the data in motion scenario, we are already going to 3 hops, right? And it was chaotic for us to maintaining several components and also several engineers working on several different things. At the same time, when the customer was using our system, he was building another component in the cloud to fetch this data and store it into a database, and then create another component for his web applications and mobile applications to fetch the data from this cloud monolithic structure. So you can see, again, the data in REST scenario are going through several different interfaces and components. So, and the customer was deploying these systems across the globe, basically, in Paris, US, and so on and so forth, and pushing all the data to the central place. And the users who are using this technology are the personnel in the factory, right? They are basically getting this data from the cloud, even though when the data is sitting right next to him in the controller, right? It sounds a bit strange to think about that, but these are the devices which we are surrounded by us today in our homes, right? The sensors basically connected to Alexa or Google Home, sending data to the cloud, and you are accessing them from your favorite apps. But today's use cases are even faced with a lot of communication challenges, for be it robotics to anything communication, vehicle to anything communication. We have robots talking to them in a swarm. They have to communicate with each other, right? And they have to do it on a wireless network. So you have to efficiently use the bandwidth on what you are spending on communicate. Similarly, in the V2X phase, we have vehicle-to-vehicle communication, where vehicle has to speak with infrastructure, and not always it can talk to cloud to see if the traffic light has turned red or blue or green, sorry. So you have to distribute the data in such a way that you could be able to access it from close to the edge, right? So that you're quicker. At the same time, you provide the network mobility to tackle these challenges which are faced today. So having said that, let's discuss the scalability challenges of DDS itself. DDS is a protocol designed for workstations and systems where you have abundance of resources. So be it bandwidth, be it memory consumption, or even CPU resources. Why do I say that? So if there is an application in DDS system, you basically discover everything. What are the readers? What are the writers in the system? What are the topics you're publishing to? Even though if you're not interested in that given topic, you've been pushed with this information to store it, to keep it around. Having said that, having the semantics doesn't let you to scale this protocol to the internet or to the smallest controller. So whenever we tried in smart city projects to scale the DDS from the local area network out into the WAN, we were faced with some of the concept semantics of DDS, be it the reliability protocol of DDS. For instance, DDS creates a session with every other, every publisher in DDS creates a session with every individual reader it is connected to. So as your readers increase, you increase the memory consumption, also the bandwidth, because you have to retransmit the data if some subscriber is slowing down. That means you cannot work with the semantics quite efficiently in a wide area network and can't even run it at the smallest controller because it is resource hungry. And comes with a lot of steep learning curve, because if you have a system and if you want to use DDS, you can't just take the DDS and try to fit it. You have to understand how DDS works, how you can configure to enable the decoupled architecture of DDS, because it's a peer-to-peer pub-sub communication where you have location transparency. You don't have to know where the subscribers are. You publish information, it basically sends it to all subscribers. And also comes with umpteen number of quality of services, which you have to configure to use the power of DDS. At the same time, you have to understand why these quality of services are there. If you, for instance, in DDS, if you want to have a reliability protocol which can make sure that all the samples are delivered to the given subscriber, you have to keep the quality of services called keep all to everything. There's history to keep all, so that you store all the data for subscribers. So if you do that, you basically also consume the memory if there is a subscriber which is falling behind. So you have to understand the concept of quality of services. If you don't exactly do not understand, you might run into issues using a lot of memory, and also at the time your application would crash. So there's a steep learning curve to get into to understand the DDS, and also how you model the data also matters when you're building systems using DDS. And works mainly in the push mode. So we publish the data, subscribers get this information. That was our experience as one of the DDS providers while working on several projects. But this is a recent report coming from Open Robotics. Open Robotics is one of the main contributors of ROS2Stack. ROS2Stack is meant to building smart robots. It provides you all the software tools. And they use DDS as the middleware stack. And this is their user experience when it comes to the challenges what they were facing. And they were looking for an alternative option to provide users with an alternative middleware. And that's where, so if you can see, most of the challenges what they have explained is something what I've mentioned before through our experience. And one of them being DDS is struggling on the Wi-Fi networks because it's not using the bandwidth efficiently. So you have to discover everything on the Wi-Fi network. That means you are pushing a lot of data into the constrained network. At the same time, to alleviate these problems, some vendors have come with extensions. So when you start using them, you get into a vendor lock-in situation, even though when you're using the open source project. So they finally decided to use Zeno to address these challenges, what they're facing in the robotics applications. So that's a great achievement for us, but how Zeno can solve the issues what in the R2X communication or in a V2X communication context, I'll get to that shortly. Let's talk about MQTT. MQTT is a protocol, mainly developed to provide client broker architecture. Most of the time, this broker is sitting in the cloud, right? And you are pushing data into the cloud, so northbound. So you cannot enable a high-performance peer-to-peer communication, or you cannot even decentralize the data to the edge, right? And this is generally, it does this job really well. Yes, it is meant for that. But whenever you want to scale the systems which are MQTT to distribute the data or provide high-performance communication, then you run into issues. So let's understand. Maybe you have heard about Zeno, some of you are not familiar with Zeno. Let's understand what Zeno does. Zeno is a pub-sub query protocol, so you can perform high performance pub-sub communication. At the same time, you can query the data, and this when you query the data, basically through Zeno, you don't have to know where your computation is sitting. So Zeno automatically resolves that and gets the information for you. So it provides a homogeneous communication from the smallest microcontrollers. It can run on microcontrollers up to the cloud, so that you can build application through these abstractions. At the same time, it provides distributed storages, so now you can have a storage on your edge or multiple edge locations which you can query transparently, even though you don't have to mention where this location is stored. And Zeno always takes the nearest path where the storage is located and gets this information back to you. On top, we also working on another project called ZenoFlow, where it is powered by Zeno. We provide data flow programming network, programming framework through ZenoFlow, so that you can build computation chains that can span from a smallest device to the cloud. But this is another project. Feel free to look through it. It's also matured a lot since a couple of years already. But let's get back to Zeno. So Zeno can work on any topology. So you can have peer-to-peer communication in a click. So you have every peer connected to every other peer. You can also have mesh communication, so you don't have to be directly connected to every other device. The Zeno can route the data through another peer. And we can also do brokered communication. If you're a client with less resources, you can connect to a router or a peer and participate into the rest of the network. And you can also do the routed communication. So thanks to Zeno routers, these are soft routers you can deploy in your edge and have the application communicate, which are deployed across the globe through the Zeno routers. And one nice thing about the router is it provides you with the plugin mechanism. We get to that shortly. And through this plugin mechanism, you can hook up a storage, and you can query these storages as transparently as you could query for any data. Like even a computation, you can also send the query to get the data from the storage. Having said that, Zeno can run on any transport. So for instance, we can run on TCP IP, UDP IP. Since we can also run on data link layer, now we can use serial interfaces or your proprietary protocol, for matter of fact, to tunnel data through Zeno. And it is built on Rust, so Rust is known for its security, performance, and safety. At the same time, it comes with great ecosystem, which basically helps the productivity of our development. And comes with several APIs, Rust, C++, Python. Even recently, we have added Kotlin binding, so you can build applications on Android. Applications can be built upon Zeno. And thanks to variable length encoding, we can have the overhead is as low as 5 bytes. So that makes it very good use case for low constraint networks or low power networks or constraint networks. And Zeno can run on microcontroller units. You might wonder, oh, Rust, how can it run on microcontrollers? As of today, we have a core, a subset of Zeno in C, pure C. So you can, so thanks to C, it has a nice ecosystem in the microcontrollers, so we can deploy even a subset of Zeno onto the microcontrollers. So we have nice blogs on our website, also nice demos on the microcontrollers. Feel free to go through it. And let's talk about the performance. So Zeno can hit as high as 70 gigabits per second on 100 gigabit Ethernet, which is very faster than MQTT, 35 times. That's a performance gain you get, and 3 times faster than DDS. And low latencies, with the recent addition of ultra-low latency support, we go as low as 5 microseconds in inter-host communication. And this is the plugin mechanism I want to talk about. So Zeno router has the facility to hook up several plugins. You can have storages as a plugin. You can also have protocols like MQTT, DDS, as a matter of fact, right? And we also support REST today, HTML, SSC. We are planning for OPC UA. Maybe if the community can contribute, we want to add other protocols like some IP, CAN IP in the future, CAN IP in the future. So now the plugin mechanism is introduced. Let's talk about how Zeno DDS bridge works, right? How we bridge the DDS communication through Zeno. So the bridge comes in 2 flavors. You can run it as a plugin, as I talked about before, to the router. So whenever the router starts, you just have to configure this plugin. I want to start, it starts up and it starts a plugin. And at the same time, you can run it as a standalone application as a Zeno peer or Zeno client. So you can have two use cases. If you want to run the plugin at the edge, or if you want to run on each individual node, you can also do it as a standalone option. So how it works? So whenever, if you are familiar with DDS, so if there is a topic, which is a data writer publishing a topic, for instance here, artist scan, the bridge detects a mirror reader for every writer and publishes that information into the Zeno, right? And then when there is a subscriber on the DDS, creates a mirror writer and creates a subscriber whenever the data is published on Zeno and publishes into the DDS. As simple as that. You don't have to change your application code or anything, just have to configure the bridge, and the bridge puts this information into the Zeno. Similarly, if you have multiple applications on the DDS side publishing to the same topic, then you can use a scoping mechanism on the bridge by, for instance here, the scoping parameter is bot1, so it prefixes the topic with bot1 so that they appear, for the next one as bot2, so they appear as two different topics. And by using the wildcard option on the Zeno subscriber, you can get the data from both the topics. And when you want to publish to a given application, you just publish on the Zeno. It gets to the respective bridge, and it strips off the prefix and sends it onto the DDS. Simple as that. And let's talk about the Zeno MQTT bridge. So it also comes in two flavors, as a Zeno plugin, plugin to the router, and also as a standalone executable. Now, for instance, and the bridge is implemented as a MQTT broker, and whenever there is an MQTT publisher publishing the data, it puts that information by calling the onPublish on call on the bridge. It puts the information onto the Zeno. And whenever there is a subscriber detected on the MQTT side, we have onSubscribe call being called and creates a subscriber for Zeno. And when data is published, it puts into the MQTT. Even here, you don't have to change your application code. Just deploy the bridge, configure the topics which you want to publish to, and Zeno does the job. And this is how you can map how the resources are mapped from MQTT to Zeno. It looks quite straightforward. How the resources are defined in MQTT and Zeno, except for the wildcards, they are implemented a bit differently, but you can see it's pretty straightforward. But you might ask, what are the use cases? What could I solve now by doing that, right? So all of a sudden now, you have DDS applications, which are, for instance, you can take a vehicle or a robot or a DDS application. You can confine the DDS traffic to the node. So now you can use the Zeno to reduce the discovery traffic of DDS, because now Zeno has a very low discovery traffic. At the same time, you could only expose the topic what are necessary for your rest of the robotic applications. So you can keep the rest of the topics which are internal for the robot, keep it there, and just only expose the topics to the fleet manager or between the robots. That drastically reduces the discovery traffic and also efficient use of bandwidth. And similarly with MQTT, now all of a sudden you can have a decentralized MQTT. So you can distribute, don't have to have the MQTT in the cloud, you can distribute it into the edge and then use the storage mechanism of Zeno and connect them and query them as you like. And all of a sudden now you can basically, thanks to the Zeno router plugin mechanism, you can have multiple protocols talking to each other through Zeno and leveraging on the Zeno topology mechanism to do a lot of nice things. And Zeno can run microcontrollers, so now we can have applications talking to devices which are running on microcontrollers. And for instance, you can also have Zeno bridge behind the NAT or even directly exposed onto the wide area network and have a communication between two remote edge locations. So demo. So we also have the live demo in the booth. I did not have the courage to get it here, so well, you know about the live demos, how it works. So we have, for instance, here the router installed in the cloud interface with the plugin, which is basically connecting to the robot, which is running DDS, and only exposing the topic like LiDAR data, and also sending the twist commands to the robot through the Zeno, and which are then later converted into the DDS. And we have MQTT bridge running excuse me, on the Raspberry Pi, which is getting the data from the button here, Zigbee button, to MQTT, Zigbee to MQTT bridge, which is then giving data to the bridge and then twisting the robot here through the bridge, through the communication through the bridge. So let's see the live demo. So here, for instance, we have the DDS integration. My colleague here having the simulation, which is using DDS in the background, running the Zeno DDS bridge. Similarly, the robot here, for instance, also using Zeno DDS bridge, running the DDS inside, and he's controlling the two robots, simulation and the robot simultaneously from the cloud interface. Another demo here, my colleague is basically using the Zigbee button to send the twist commands to the Raspberry Pi, which is then using the Zeno bridge, sending the MQTT messages through the Zeno bridge to the robot. So whenever he clicks the button, he basically twists the robot. So that's a demo. And when he does a double click, it twists the other way around. So you can see here the integration of DDS, MQTT through Zeno, right? So final remarks, as I explained the use case in my start of the talk, I think if we had a protocol like Zeno back then, I could have had the project defined through homogeneous communication from the microcontroller up to the cloud by using one protocol, right? But today's use cases like V2X, R2X can be addressed better through our protocol, and this is something we see from our users. When they deploy it in such use cases, they find Zeno to be very, very useful for their several use cases, which they are not able to run with other communication protocols. So it comes with impressive performance. And feel free to try Zeno at our website, so you can have all the information, documentation, and blogs here. And also, this is our GitHub repository. And we are always available on Discord if you have any questions on how you want to use it, and so on and so forth. So that's it from my side. Thank you for your attention. So any questions? Sure.
Yeah, I do have. I mean, first of all, thank you for the very nice presentation. The one thing that I was just wondering, because for industrial applications, honestly, I am aware that people are using UA as
yes.
And I see that you guys.
Oh, sorry. I could have given the mic.
Yeah, so again, for the recording, thank you very much for your great presentation. While listening to your session, I was just wondering, rather from the industrial perspective and background, most of the use cases are actually using OPC UA, right? I see that you guys have an adapter for that, but what is your take on that? Are you planning to also get closer to OPC UA, or what are the benefits from DDS that you say, okay, we have to stick to DDS over OPC UA, or you say your applications are rather not industrial, or no, something else? So
we have, for instance, a user called Flex. They are creating soft PLCs, and they are using Zeno to get the data from OPC UA and other industrial protocols into the Zeno, which makes them to deploy applications on the soft PLC very efficiently. As of today, we still are working on the OPC UA, don't have the plugin, but we are working on those aspects to implement the OPC UA plugin on the Zeno. Maybe some contribution from the users would come in, but we also see Zeno, of course, be part of industrial use cases. And there is also demand to have industrial use cases where these days you are not able to update your hardware from the cloud and provide new features to the customers, enable nice things on the cloud, on the factory, for instance. And these are some things the protocol like Zeno can enable you, because it is hardware agnostic. It can run on any device and can also use any API. So yes, we have several requests coming in, but soon we might provide the OPC UA interface. Yes.
Thank you.
Any questions?
Okay, so thank you for your presentation. I have only a question about, for example, edge node failures. So, for example, if we have Zeno peer, and for any circumstance we have a network disconnection. Is there any reconciliation of data after that?
Yes. So if you go back to my first slide. Oops. So when you deploy Zeno through the database storage mechanism, and you can have redundant edge routers using also storing the same data, and when these are connected, Zeno always tries to align the data between them, and whenever you have any failure, you have another resource, other storage, which is storing the same data. And also, what Zeno can do is when there are disconnections between these two routers, and whenever the connection is back, they try to align together, and so that you have a similar truth of data on both sides. So that mechanism is inbuilt. There's also a nice blog on our website, how we do this alignment protocol, how it works. So I would recommend you to go through that as well.
Thank you.
Yep. Questions? Sure. Yes.
So thanks first for the great presentation. I just have one question concerning the functional safety aspects, if they are respected in your development.
It's in automotive context.
Yes, because if we want to use it in the automotive context, then we need to consider this too.
So we are working on Zeno implementation for the ASIL-D, ISO 262 ASIL-D safety context. So yes, that will be on the commercial side of Zeno, for instance.
So it will be part of the next releases?
Since the open source is 100% open source, it is available out in the GitHub, but what we want to do on the certified side, it will be part of our commercial offering.
Okay.
So it will be available in next releases, yes. In first quarter of 2024, we are supposed to have ASIL-D implementation.
And what's about the cybersecurity aspects?
So we have mutual TLS implementation as of today. And going forward, we also want to provide access control on what resources one can publish and what resources you can subscribe and who has control on what part of data. That will be our next step. But as of today, you can also implement the mutual TLS.
Okay. Okay. Thank you very much.
You're welcome. Any more questions? We have some time. 3 more minutes. So. All right, then thank you very much for being here. It was a pleasure to explain you what we are doing with Zeno. So as I said, we are very active on Discord. Feel free to reach us out. We are hungry engineers working on changing some communication paradigm, what we are using today. So feel free to reach us out. We are always there. And we have a booth here. If you want to see the live demo, pass by, and we will try to show you the demo as well. Yeah. Thank you very much. See you.